Hello, everybody. Today is Monday, September 14th, and here is the plan. Whether you are joining us virtually or if we are connecting right now live, I am looking forward to getting started on Unit 1 and actually teaching you some math. What you should have out right now is your Chromebook, headphones, pencil, and your Unit 1 packet. A calculator might also come in handy, but if you don't have one with you today, that's okay for now. You do have some homework today, but I'll go over that a little bit later. So we're going to jump right into it. And today you are going to learn how to classify numbers using the real number system. Here's a reminder right now, if you haven't done so already, please pause this video, hop on over to the attendance quiz and complete that. It is required for you to do that every day by 1 p.m., whether you're in school or outside of school. So do that now if you need to. You should have your packet out right next to you for those of you who are in class. Just a couple of tips here. I'm gonna make this bigger. I know with these triangle tables it's a little bit tricky, but make space for your packet, your pencil, as well as your Chromebook, and put everything else on the floor. So if you've got your big binder, take your packet out and place it next to you. If you are at home, I hope that you have set up a spot for yourself to work that is free of distraction, and hopefully that you have space to spread out. That will help you to be successful throughout this journey. Your headphones are required, especially when you are in school. Of course, if you're at home, I guess that's up to you. But if you don't have headphones, please contact someone in the main office. There are some extras that you are able to check out and use, but you're going to need those when you are in school so that you can focus and not be a distraction to the people around you. And then if you haven't learned how to do a split screen, there is a link here that you can access through the Google Slides that explains to you how to do the split screen. But I would recommend having this screen up, and then those of you joining me through WebEx, I'm going to teach you how to have me or the WebEx screen available right next to you, so you're looking at both. Those of you who are at home, if you just Google how to do a split screen on your Chromebook, you should be able to find information on how to do that. And a good reminder for all of us, when it feels overwhelming, just keep swimming. All right, well, like I mentioned before, today, the I can statement, your I can statement is, I can classify numbers using the real number system. Something for you to consider. Why might we classify things? What is the purpose? When do we do it, especially in math? Why do we classify? Specifically in math, but I think this also goes I think this is also relevant for any time we classify, but we do it to help us notice and wonder. We do it to help us recognize patterns, and we do it as a mathematician to help us describe those patterns. And so if you recall from last week, we talked about sort of what does that look like to be a mathematician and to do math each day. Today we're going to be a mathematician because we're going to be doing all of these things. Can you think of any other content area that uses a classification system? Those of you who are live via WebEx, why don't you go ahead and add a thought, if you have one, to the chat. Those of you who are at home, just think about that question and maybe jot it down in your notes. One that pops into my head right away is science, and you're probably not there yet in your curriculum, but eventually in 7th grade life science, you will learn about a classification system that scientists use. So the real number system helps us to stay organized, and it allows us to look at numbers as a group and discover how they behave and they interact in the universe. This is one of the major building blocks for mathematics, and especially for algebra. So I have an analogy for you. And honestly, you guys, I'm not sure if I can move this little thing around Oh, I turned myself around. So, oh, I can. Here we go. I don't know where you want me. How about right here? Okay. I have an analogy for you. I gotta move myself again. Sorry. I'm going back over here. Think about planet Earth and Jupiter, two completely separate planets. We know some things about Jupiter, but we know a lot more about planet Earth. One thing we know about planet Earth is that within planet Earth, there is a continent called North America. If we want to be more specific, we can say that within North America, there is the United States of America. If we continue to classify more specifically, we live in the state of Minnesota, which happens to be in the United States, which is also a part of North America and also a larger part of the planet Earth. Now, if we think just about that inner circle of Minnesota, we know some things about Minnesota that we recognize as a pattern, that we can describe and that we can generalize, and that falls within the United States and North America and planet Earth, but it just gets a little bit more specific for us to look at those behaviors and things that happened in Minnesota. And then we could keep going to be more specific. We could look at Woodbury. We could look within Woodbury at a specific neighborhood. And so this is just one example. It's an analogy of how you might classify something non-math related. In math, we use something called the real number system. And if you want to go ahead and open up to this page in your packet, it should be one of the first pages. This is just one graphic organizer that represents the real number system. I think there's probably better ways to create this graphic organizer, but this is just one of them. So how might you organize after we kind of go through this? I'm wondering if you have a different way of organizing in the form of a graphic organizer that might work better for you. I don't know. So if we think about starting really broadly, the most broad category that we can classify numbers is the real number classification. And for this purpose, for this year, all of the numbers that we are dealing with are real numbers. There are such numbers called imaginary numbers, and if you're interested, go ahead and Google that, because you'll read a lot of really cool information about imaginary numbers, and eventually you'll get to learn about imaginary numbers. But this year in algebra, we're going to focus on real numbers. So all of the numbers that we classify are considered real numbers. There are two main categories of real numbers. There are irrational numbers or rational numbers. So we're getting a little bit more broad, but both of those are still pretty large groups. So I'm going to focus on just the rational numbers here. And I have a whiteboard behind me, and I'm not sure if it's going to show up backwards to you or not. But we're going to look at some examples of what a rational number might look like, what an integer is, a whole number, and then a natural number. And I'm actually going to start with the most specific. So the most specific classification that we use are natural numbers. I'm like sweating, it's so hot. That's why my face looks like this. So natural numbers, a really basic definition is counting numbers. So if you think about when you first learned how to count, my 4-year-old is working on this in pre-K, but really he started before that. You typically start with the number 1 and you go upward. So 1, 2, 3, 4, 5, etc. Those are the most basic classification of numbers, and we call them natural numbers. And so there are symbols that we use to represent each level of classification, and the symbol we use for natural numbers is naturally N. And so go ahead and fill your notes in with that symbol N. And then just list some examples. So like I said, 1, 2, 3, ... ellipsis means so on and so forth. And to the right in your notes, I would maybe just jot down this definition that says counting numbers. It just gives you a little bit better explanation of what those are when you look back in your notes. If we want to broaden the classification a bit, we move up to the next level, which are whole numbers. And whole numbers include all of those natural counting numbers and the addition of 0. So at some point, people are like, wait a minute, I get these numbers are 1, 2, 3, but what about 0? Like, we have to have a value that represents nothing. And so we need to make a bigger classification system that includes that number. And so whole numbers do that. They include the number 0. The only difference between natural numbers and whole numbers is that 0 is included as a whole number. The definition that I came up with, if you can read this, says natural numbers plus 0. Maybe jot that down to the right, on the right of your notes. Then people lived in Minnesota and they were like, wait a minute, we need numbers that represent something that's less than 0 because we live in the winter time where the temperature falls below 0. And so they decided we need to broaden our classification system. We need to start adding a larger classification, and that is where we come up with integers. And the abbreviation for integers is actually the letter Z. You'll see why as we go, because there's irrational and integer, and if we use the letter I, which is what would make sense, it can be confusing. And so I always say in my head integers, and that's how I remember that it's a Z that we use, but definitely write it down in your notes so you don't forget that. So integers are whole numbers and their opposites. So we still include 0, all of the positive counting numbers, and then their opposites. So -1, -2, -3. Basically, think of the number line. If you're in my classroom, you can look straight above the smartboard. The number line represents all of the integers that exist. Not all of them, but it has all integers on it. Then people are like, okay, cool, that's most of the numbers or a lot of the numbers, but actually sometimes we need fractions and decimals. So sometimes we need to represent a value that falls in between two integers. And so what do we call that? So we need to broaden this again. And so the next level for classification is called rational numbers. And rational numbers, we use the abbreviation of Q. I don't know why, because there's also real numbers, RR. So don't ask me, but Q is the abbreviation that we use for rational numbers. And rational numbers are, like most numbers that we work with, are rational numbers because though they can include any fraction, any decimal that terminates, which means it stops or ends, or it repeats. So repeating decimals are rational. Decimals that end, like 2.75, that's rational. And then any number that can be written as a fraction, a over b. And so most numbers are rational numbers, including all of the natural numbers, all of the whole numbers, and all of the integers. They all exist underneath that umbrella of rational numbers. So if you think back to this analogy, Woodbury is still a part of planet Earth. Minnesota is still a part of planet Earth. All of these classifications lie within planet Earth, not the other way around. So planet Earth isn't in Woodbury. And so it kind of works one way but not the other. And that's true for the real number system as well. And so the definition given here, all fractions and decimals that end or have a repeated pattern, that's really important. I said fractions, decimals, perfect squares. And so maybe jot that down beside it. And then the other category is called irrational numbers. And irrational numbers are what I classify as messy numbers. And so these are decimals that never end. They have no repeating pattern. They're kind of mumbo jumbo. The most famous irrational number is, anybody want to take a guess? Pi, because pi is a number that goes on and on and on forever. There's no patterns. There are repeats in digits, but not anything that's a repetitive pattern. And so pi is an irrational number. Also, numbers like the square root of 2 or the square root of 7. Those, if you type into your calculator, give you a big long decimal, and it's messy and it's irrational. And so that is how we define irrational. So I'm going to leave this slide up for just a second. Pause the video if you need to make sure that you have your notes completely filled out, and then we're going to move on. We're going to take a minute to just try and classify these numbers in a couple of different ways. So the directions here say name all sets of numbers to which each number belongs. And so your job is to look at that number. Number one, simplify it if you can. That's going to be important. And then classify it. For example, the number 30. The number 30. For me, it is helpful to look at organizing the real numbers in this way. So kind of like that planet Earth analogy that I used. And if you look in your notes, you'll see this here in a second, but I always start sort of in the most specific classification. And if a number fits in there, then I know that it fits in all of the rest of them above there. And so number 30, is 30 a counting number? When I first learn how to count, do I eventually get to 30? Sure. There's no decimals, there's no negatives. Natural number is the most basic most specific form of a number, and 30 falls in that category. And so I would label 30 as a whole number, as a natural number, n. And because it's a natural number, it's also in the whole number classification. It's also an integer, and it's also a rational number. And then the biggest umbrella is real numbers. So it's technically also a real number. And so when it says name all sets of numbers to which each number belongs, I would actually write out all of those classifications. You can use either the abbreviation or the word if that's easier for you. Let's look at number 2, negative 11. So how do we classify negative 11? Again, if you look at this most specific classification, is negative 11 a counting number? I'll tell you, my son Eli does not know about the number negative 11 yet. And so no, it's not a natural number. So then we go out a little bit more broad. Is it a whole number? Well, no, because whole numbers are just natural counting numbers and 0. So it's not a whole number. Is it an integer? A whole number or its opposite. Think of the number line for whole number or for integers. And yep, negative 11 falls on that number line, and so therefore it is an integer. And because it's an integer, it's also a rational number. So I would classify negative 11 as Q for integer and Z for rational. It's also a real number, so you could put R if you want to. But all of these are real numbers, so I'm going to leave that up to you. Number 3, 5 and 4/7. So definitely not a natural number no, it's not a natural number. If I go back here and look at this graphic organizer, 5 and 4/7 does not fit here. It is not a whole number. It is not a number that falls written on the number line. Is it rational? Well, rational numbers are all fractions. Any fraction, if it can be written as a fraction, it is rational. And so I say, yep, it's a rational number, and because it's rational, it's also real. And so the way I would classify that is Z for rational and R for real. Now, number 4 says the square root of 21. I don't know the square root of 21. So grab your calculator. If I had one with me, I would show you this, but I can't right now. The square root of 21, if you type in your calculator second and then the radical symbol is this. So second and then the radical symbol and then 21, enter. And then if it's just telling you it's the square root of 21, there's a way to convert that to the form of a decimal. And this is going to be a key that you use a lot on your calculator. Some of you might already know it, but on the bottom right-hand corner, there's this little double arrow key. I think it's like right above enter. That converts things between this form and decimal form. And so if you're checking a square root or a radical, type it in, press enter, and then right above enter, click the double arrow key because it will convert it to a decimal. Then you can see that decimal and you can see that there are no patterns, no repeats. It's a hot mess. Therefore, it is irrational. Kind of stands out here on its own. Or go back to your definition. Messy numbers. Lots of square roots, if they're not perfect squares, are irrational. The number 0. What is the number 0? It's not natural because we don't learn to count with 0, but it is in the next classification level, which is whole numbers. And because it's a whole number, it's also an integer and it's also rational. So I'm going to just have you try a couple of these maybe on your own. Some of them get a little bit tricky, and but maybe pause this video, see if you can do a couple, and then come back and check. Some of you maybe didn't make it too far, and that's okay, because there's something new in all of these examples. So number 6, there's a square root and then a negative on the outside. So we actually have to simplify first. Simplify before you classify. The square root of 9, do you know it? If you don't, type it in your calculator, but the square root of 9 is 3. And then the negative is on the outside. So that means negative 3. How would we classify negative 3? It's not a natural counting number. It's not a whole number because it's not positive. The square root of 9 is, but not a negative square root of 9. Is it an integer? Well, that's a whole number and its opposite. Would negative 3 be on the number line? Yeah, so it's an integer, and because it's an integer, it's also rational. How about number 7, 6 over 3? Go ahead and type that into your calculator using the fraction key, A over B, or the N over D, or depends on your calculator. N over D is how you type in a fraction, and if you press enter, and then that little double arrow key again, it should simplify it to 2. 6 over 3 is 2. We simplify before we classify. 2 is a counting number, so it's natural, and because it's natural, it's all of the ones above it. So natural, whole, integer, and rational. If you're getting the hang of this, you're welcome to finish these examples on your own and then come back and check. If you want to keep going with me, keep going with me. Pi, automatically, anytime you see pi, it's irrational. It's messy, no repeats, it's irrational. Number 9, repeating decimals. Go back to your definitions. Rational numbers are fractions and decimals that either end or repeat. So repeating decimals are rational. This one's kind of interesting, and I don't know if you can see it, but it says the square root of 144 divided by 3. If you don't know the square root of 144, you need to learn how to type that into your calculator. Second, the radical symbol, 144, enter. Square root of that is 12. So then we simplify 12 over 3. Oh, that's just 4. It's a fancy number that's actually not fancy. So 4 can be classified as natural, it's a counting number, whole, integer, and rational, or NWQZ, and it's also real. Number 11, negative 2.875 is a decimal that stops, it terminates, it ends. Therefore, it's rational. It's not an integer because integers can't have any decimals. Those don't appear on the number line. And then number 12 is super fun. Figure out if you can put that into your calculator. You can, and it will help you, and I recommend doing that. But otherwise, what is any number divided by itself? For example, 5 divided by 5, 2 divided by 2, 17 divided by 17. The square root of 17 divided by 17 follows that same pattern. So as a mathematician, if you can recognize, hey, anything divided by itself is always 1. then you know what you're classifying is just one: natural, whole, integer, and rational. For those of you just back in, here is what this would look like in just abbreviated form. Pause the video if you need to double check, and then let's move on. This is a live link in the Google slide, and so I'm going to just click on it to show you what it is. It's just kind of a fun online game. Allows you the opportunity to classify numbers and see if you're on the right track. And so it's a drag and drop. The number 0, now here, this looks a little bit different of a graphic organizer, but the number 0 is not natural, but I'm going to show you what happens if I get it wrong. Right? So embarrassing. Just kidding. I do know that 0 is a whole number, so I'm going to plop it there. And since that's the most specific place, that's where I'll put it. -1. I know -1 is a real number, so technically if I put it here, that wouldn't be totally incorrect, but let's work on learning how to classify in the most specific. So is -1 natural? No, we don't count with -1. How about a whole number? Nope. An integer, is it on the number line? Yes. Yay. 1.5, rational. This is another way to write pi. Hot mess. Bam. Square root of 9, that's actually 3. 3 is a natural number. Cool, and there's a little timer here just for fun. There's different sets, so maybe give it a go. I did post a link for you to practice also in the to-do list, but that website's a pretty good one. Just another graphic organizer, a different way of looking at it, and the directions are a little bit different, so let me clarify. It says place the letter of each value in its location in the real number system. We're talking the most specific. So 7 is rational, and it is an integer, and it is whole, but I only want you to place it in the most specific. And so the most specific place that 7 falls would be in natural. So you would just put the letter A here. Remember to simplify before you classify. So these fractions, use your calculator to help you simplify them and then classify them by putting them in the most specific location in this graphic organizer. Remember that repeating decimals are rational because there's a pattern. We know what to expect. And then please take a look at letter K. Letter K is a radical. It's the square root of 4 over, honestly, I can't see that, but it's another perfect square number, I know. If you type that into your calculator, you should be able to see that the square root of a fraction, you can actually just separate the radical. So it does the square root of the top number divided by the square root of the bottom number. And you'll find that it's not quite as fancy of a number as you may have first thought. So pause the video, give these a try, place them in the most specific location in this organizer in your notes, and then press play to see how you did. How did you do? All right, in your notes, these questions are kind of just stretching your thinking a little bit in a different way. And so I want you to take a look at them and try your best based on the information that you now have about the real number system. I'll do the first one with you. Which expression does not name an integer? A, -15, B, 6/14, C, 0, or D, 12/6. Well, here's what I know. I need to simplify before I classify. -15 I know is an integer because it's a number that I see on the number line. 0 is a whole number, and all whole numbers fall underneath that same, or underneath the larger circle of integers, so that's okay. 6/14 I can simplify to 3/7. 3/7. I'm going to check that with my calculator to see what that is as a decimal. But 12/6 is just 2, and 2 is an integer. So kind of by process of elimination, I'm going with B. Pause the video, try these out, come back and check. there you have it. I have no idea if I'm in the way from what you guys are looking at or not. Okay, so there you have it, my friends. Ooh, this is the real number system card sorting assignment. Sorry, I gotta go back. If you click on that, it's a live link that brings you to just the example of it. But really, your homework for today is as follows, and you have the rest of the time to work on it. I'm hoping that you'll finish in class, but if you don't, those of you who are in hybrid, you have this afternoon to finish. Make sure that it's done no matter what for any group by tomorrow. Homework number 1 in your packet looks like this. It's very similar to the notes that we just did. And so refer to your notes if you're not sure about the directions, exactly how to label or to do these questions. The directions are a little bit different for each section. So refer to your notes. And then there is an optional Google Slides assignment that's just kind of a drag and drop. And it's just for extra practice, or if you have more time and you're in class, you're welcome to do that. One other thing is, I think almost every single one of you has completely finished the Tell Me About Your Selfie assignment. I've graded those, and some of you, I left some comments. Thank you for doing that. I really enjoyed spending my weekend getting to know a little bit more about you, so way to go on that. I know last week was overwhelming, and you were probably just kind of stressed about all of the things, but thanks for getting that done, and I appreciate it. The math survey, I think I'm like in the 95% of people that have completed it, but that's still an active link, and so go back into last week if you need to finish that. Designing your cover, that's just for fun as you see as time allows. And so I would love for you to come up with a figure me out with 3 to 5 numbers that are important to you. Put those on the front of your packet in some way, marker or color or something, bubble letters, something fancy to make it stand out. And then on the back, you can describe why those numbers are important to you, so that as I'm getting back and seeing some of you in person, I can come around and just take a peek at those and continue to get to know more about you. So those of you who are at home learning today, I hope that this was helpful. I am still just learning, and so please, if you have feedback, send me a message, but also use each other as a resource. Reach out through, Schoology Messenger, or get each other's phone numbers, because we're going to need each other throughout this school year. As always, you're welcome to go back and re-listen to things as you need to, but otherwise, I'm just going to run through one more time what this folder looks like for week 2. Today's Monday. Your attendance should be done. And then if you click on this to-do list, it goes through everything that you need to complete for today. The video that you're watching should be posted right here once it's done uploading to YouTube. The practice link of that game that I showed you is right here. And then your assignment, homework number 1, due today. Those of you who I get to see, I will be checking that when I come back. The Tell Me About Your Selfie, make sure that's done and submitted. And then here's the real number system sort. You'll see it as an assignment in your Schoology, but just know that it's optional and you don't have to do it. And then the design your cover instructions are right here. I hope you are all doing well and staying healthy and getting used to this new normal. If you have any questions at all, please don't hesitate to reach out. Have a fabulous rest of your day, and I look forward to when we can connect again. Thanks, everyone.